Hello guys, I'll be explaining the internal architecture, how our project works. So first we'll assume that there are 1000 delivery points in a particular place, and then 1000 delivery points and radius of 4 kilometers, or let's assume 5 kilometers, and then we'll have 10 delivery guys. So now the first step is where we plot down all the points. By the points I'm indicating that these are the coordinate points like latitude and longitudes. Yes, let's assume that these are those 1000 points here, and then what we do is our next step is to cluster this. On what basis we cluster this is based on the number of drivers. So if there are 10 drivers, we break this down into 10 clusters. So for example, this is the thing, and now we will break this down into 10 clusters. 1 2 3 4 5 6 7 8, so on there are 10 clusters. Let's assume there are 10 clusters. So let's break this further down so that how the internal architecture works in an individual cluster. It's going to remain same for the remaining clusters too. Okay, let's think this is the particular subclass. This is the cluster number 1 or something, for let's assume it. So how this works here is we'll have to plot down all the points. And now for example we'll have eight time slots. We still don't know what the time slots are, so we'll assume there are 8 time slots. Okay, and if it starts from, for example, from 10 to 11 and it's from 5 to 6. Okay, so there are technically 8 time slots and an hour of break. Okay, now what we do is we'll open the time slots. The user gets the opportunity to select the time slots. So what happens here is, for example, if this time slot, let this point be assumed. This is a delivery location. By the point I'm trying to indicate, these are delivery locations. So let this point be as A. He's the customer A. What happens is, if customer A chooses a time slot 10 to 11, what happens is we'll have to figure out and this thing is fixed, the first client, because he's the one who chooses the first position, so there's nothing to depend on. So we will give him the point 10 to 11. So the next thing what happens is we'll have to choose if this is the point B. Point B is customer 2. Now for example, if he chooses a time slot, same time slot 10 to 11, what happens here is basically we'll have to calculate the distance the time between these both points. So if the time is if for example now I will have to explain the time architecture. Now for deciding how this time works, I'll have to explain the time constraints we have used in this concept. So how the time constraint works is, for fundamentally, so what we do is there are 1000 points, 1000 total delivery points. So there are 10 delivery guys. So each person gets 100 points approximately. So what we do is, now these 100 points are being divided by 8. Why 8? Because there are 8 time slots. Okay, so this is the number of deliveries for an individual driver and the number of time slots involved. So this will somewhere give us around 12.5. Let us assume this is 13, for example. Okay, so now what we do is, the next step is this fundamentally tells us that every time slot we'll have to deliver approximately 13 deliveries. And then now what this works is, now what we have done is now we have got that in a particular time slot we should deliver a minimum of 13 deliveries. So what we'll do is we'll assume that every time slot is working for 1 hour. So 1 hour has 60 minutes. So 60 minutes by 13 somewhere gives us around 13.6 minutes. So we'll have to figure out every. Now for example, here we have got 13. This 13 indicates the minimum number of deliveries we need to be delivering in a time slot. So what we have assumed here is every time slot works on a 60-minute time roll. So there are 60 minutes divided by 13 will give us somewhere around 3.6 minutes. So every delivery gets around 3.6 minutes. And what this 3.6 minutes indicates us is we can add a buffer to this. It may not be directly 3.6 minutes. We can add a buffer based on the traffic and different factors. This is where our AI model comes into picture. We use bias and this thing concepts here, which will additionally add us something and tell us what the 13 time slot is. Now we'll have to figure out this we'll assume that this is somewhere around 4 minutes. Now what we do is we'll come back to the example here. Okay, now what happens is, let's assume an individual cluster. Let this be a particular individual cluster where there are several points in this. Now what we'll have to do is, I'll explain you how the time constraint works here. For example, let's assume the buffer time, the time constraint to be as 4 minutes. Okay, now if point A is the first one to choose a time slot 10 to 11. Okay, 10 to 11, and let's assume this is point A, and if point B also chooses the same time slot 10 to 11. Now what happens is, we'll have to check our algorithm basically checks the distance, the time taken between this point to this point is less than 4 minutes. Yes, if it is less than 4 minutes, we'll accept it, we'll accept the delivery. So now what happens is, we have chosen this and this to be the delivery locations. And now for example, if this point and point C is is more than 4 minutes, so what happens in this case is, our algorithm will automatically reject him the time slot 10 to 11 and offer him other remaining time slots. Okay, now what happens is, after we select, so here what we have chosen is, there are basically 13 this thing delivery locations to be covered in a particular time slot. So what our algorithm does is, we sort down all the locations for the 10 to 11 time slot, and then what we'll have to do is, we'll have to use a route optimization algorithm. We'll plot down all the 10 to 11 algorithms, all the 10 to 11 delivery points in a particular array, and then we'll plot this down. For example, let's assume this is the thing, for example, randomly like this. We'll assume there are 13 locations. Now our route optimization algorithm will figure out what is the best way to go to these points. Okay, and here what we are trying to implement is, we retain fuel efficiency, we figure out fuel efficiency, and we can use our delivery guys in a better way. And thank you guys, this has been what I've explained. We have taken certain points in our Bangalore city and we have plotted those points. These are some of those points. And what we have done is, we have fundamentally divided this into 20 individual clusters. So why we have done this is because, as we have already told you, that there are 2,500 points. Those are 2,500 delivery locations. And there are 20 delivery guys. So we have divided it by 20 clusters. And what we have done further is, we have figured out how many points are there in individual clusters. What we have done here is, we have used the K means for clustering. So what clay means does is, it clusters the points based on the this thing, based on the nearby points. So here you see the point differences. So certain points has more, certain points has no. Based on more further training, we will be able to achieve a very constant rate over here. And then what we have done is, again, we have found out the this thing, latitude and longitude for a particular cluster, so that we focus. Again, we are telling this process is going to remain same for everything else, but what we have done here is, we have taken one cluster as a reference, and then we are going to focus on it. So this is that cluster. This is actually the 18th cluster here. You'll be able to see that. So we have found out all the latitude and longitude points for in that cluster. Same goes on here, but no, but when we click on this thing, we'll be able to figure out this thing. Yes. And now what we have done is, we have used another program here, uh, that would divide all the clusters into random points, or random points basically. We have assumed random points because it will divide us into 18. So in that particular cluster, there were 136 points. So 136 divided by 8. Why 8? Because there are 8 time this thing slots. So when we divide this somewhere around 18, we get particular for a cluster. And so what we have done is, our model has figured out that these are the points that is going to remain there. And then what we have done is, we have plotted those points. And what we have plotted is, we have plotted this, and then we have route optimized for these points. And the result looks something like this. These are the first stop, second stop. You can take a look at that. This is how it's going to look. And then what we have done furthermore is, we have actually found out the distance between every point. Just a second, guys. Yeah, so these are those cluster points which we have taken, and then what we have done is we have found out the time between this. So here the buffer time was somewhere around 3 points, not 3 point. Yeah, it was around 3.6 minutes. So what we have done is this thing remains same, so that we'll be able to deliver 18 and 18 deliveries in that, and we could figure out this is how it works. Thank you. Thank you.